Hi, and welcome back. I am Joseph Komorowski, your professor. Today we're going to go over 1.5 in Hurley's Introduction to Logic, 13th edition. 1.5, argument forms, proving invalidity, and the counterexample method. Okay, so here's what we got. Let's go to your book. All right, okay, right here. Okay, so here we go. Proving invalidity. So I'm just going to read to you. This section explores the idea that the validity of a deductive argument is determined by its form. This idea was suggested by the arguments in Table 1.1 in the previous section. All the arguments in the valid column have the same valid form, and all the arguments in the invalid column have the same invalid form. The form of an argument illustrates the argument's internal structure or pattern of reasoning. If the pattern of reasoning is good, the argument will be valid. If not, it will be invalid. So just as a quick review, remember proving validity in section 1.4, part A, remember because I broke that section up into two parts, is basically you accept the premise as true, or premises, if there's more than one, you accept them as true, and then you say, if they were true, would the conclusion follow? And remember, I was telling you validity was hypothetical. Even if the premises are false, that doesn't matter. You assume that they're true, and then you ask, would the conclusion follow? So if that was the case, if the argument was valid, the conclusion follows from strict necessity. Remember, the deductive arguments were 100% all or nothing, following with certainty, whereas the inductive, they were probable. So here we go. Now he's going to give you an example. All A are B, all C are A, and all C are B. Now, I've got a separate document that I want to show you, because when you look at this seems kind of abstract. Like, really, what's going on? You could see this right here. Over here, first example, right? He's saying, let me look. I think it's all A or B. Yeah. All A are B. So think of a B as a super broad category, like of things out there. You could think of it like toys, right? And then like Legos are types of toys, but we don't have to know what they are yet. We'll just say, first premise, all A are B. In other words, this B is a huge circle, and there's a circle A that's inside of B. That's all premise one is saying. And then he's saying, let's look at the second premise, all C are A. So inside of the A circle, there's another circle, the C, that's saying all these C's are inside the A's, right? You're just demonstrating premise two. And then the conclusion says all C are B. All C are B. So what this is saying is, remember, we're trying to see if this is valid. So premise one, if all A are inside B, and if all C are inside A, then all C are inside B. We can see that just by looking at these circles, and it looks pretty easy to see that. And if you didn't see it right away, look at this a couple times, and it'll be obvious. This is the A circle, this big one right here, right? Because I have A inside of it. And we're just saying, look, this is inside the B circle. And then we have another little C circle, and that's inside the A circle. And you could just see that if A are B and C are A, then C is B. Why? Because the little C circle is inside the B as well, okay? So I believe that those circles are real easy to see what he's trying to say here, because it's less abstract. Again, why is it less abstract? Because you can see it with the circles. It looks pretty obvious. Okay, so we'll go down. Yeah, and he basically says, if A, B, and C are thought of as referring to groups of things, it's easy to see that this form is valid. And then he basically unpacks the premises. Now let me give you an example, okay? Let's say B are toys. And I say, look, all Legos, all A, are toys, or are B. All space Legos are Legos. Therefore, all space Legos are toys, right? Because Legos are toys and space Legos are also toys. You can think of like any number of things. Think of B as food. All Mexican food is food. All burritos are Mexican food, so therefore all burritos are food. You can think of it, like I said, you could do music, you could do toys, you can do food, you can pretty much think of anything. Sports, you know. So let's go down. And then he says, he gives you an example. All A or B, and he says all sporting events are engaging pastimes. All baseball games are sporting events. Therefore, all baseball games are engaging pastimes. So again, you can see this right here, which is the same as this. Think of this as the abstract form. And think of this as you're putting language to that abstract form, right? So you can look at this, again, as in this circle, sporting events, pastime, baseball, and you can see the connections there, okay? So like I said, you could do it with many, many things. And he said this argument's called the substitution instance. So you actually don't have to know anything about, yeah, let's just hold that thought. I will come back to this, but let's go down here and look at a bad form. Right here. All A or B, all C or B, all A or C. It doesn't really matter what these are. We can go to our circle chart over here. So again, premise one, all A or B. Okay, all A or B. Got it. Okay, I have an A circle inside of a huge B circle. No problem. Premise one, got it. Two, all C or B. No problem. All C or B. I got a little C circle inside my huge B circle. No problem. And then conclusion, all A or C. All A or C. Wait a minute. So I got premise one here, all A or B. Premise two, all C or B. And then conclusion, therefore all C or, all A or C. Well, it's not like over here where there's a circle inside of a circle. These are separate circles. So it turns out that if premise one was true, and if premise two is true, the conclusion would not be true. All A or not C, or all C or not A, they are in completely separate circles. And why do I do this? I'm showing you it's invalid again, because seeing these circles is a little bit easier than seeing this premise one, premise two, premise three, right? This abstract notion. You can see it in the circles. It's completely obvious that even if these two premises were true, this would not follow because they are not a part of each other like they are over here, okay? So again, you can look at this chart a few times. Once again, this side over here is valid. Once again, this side is invalid. And once again, this is premise one, this is premise two, this is conclusion. This is premise one, premise two, conclusion. And you can see that this conclusion doesn't follow even if these premises were true, okay? And you can plug in, food, toys, music. As long as you keep your A's and B's the same, and your C's and B's the same, and your A's and C's the same, you'll see that they just don't connect the right way. So, and he shows it to you this way. I think my first example, like a huge block with like circles in the middle. I think my diagram's easy because it's I'm keeping the circles consistent. I'm not like using a huge rectangle. I'm using a circle, and then another circle within that, and another circle within that. Okay. What are we getting at? He's trying to say, well, let's just look at another example. All A or B, all cats are animals, seems totally true, right? All C or B, all dogs are animals, no problem, that's true too. And then if you keep that same structure, all C or A, therefore all cats are dogs. What? That's totally absurdly false. And he's going to say that's the point. If you come across some sort of form that's bad, no matter what you plug into it, if you use cats, animals, fish, whatever, as long as you're consistent with your A's, B's, and C's, you will always have two true premises and a false conclusion because the form itself is just awful. And it just says, hey, even if these two were true, would this follow? No. And we could see it as obvious as the sun. All cats are dogs. We know that that's false, okay? So this will come together. You can read this part right down here that I highlighted. That just gives you a little bit more detail. But now let me make it obvious. So Oh yeah. So what he does is he says, and you'll see some homework examples. He'll say, look, I'll give you an example here. Since some employees are not social climbers and all vice presidents are employees, we may conclude that some vice presidents are not social climbers. Since is a premise indicating word, right? And we may conclude, we know that that's a conclusion indicating word. So we see two premises here, since, blah, 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 and all. So he's going to say, let's translate this. Since some employers are not social climbers, since some employees are not social climbers, so say some employees, we'll just say some E. Take the first letter of the employees, make it E, right? Are not S, are not social climbers. So whatever this is, he's just going to say that we can symbolize it as an S. And this is what's happening now in this section. And you're going to see a lot of, well, anyways, sorry. So what he's doing is he's symbolizing. He's saying employees will symbolize it as an E. Social climbers will symbolize it as an S. And then we'll go on. And he says all vice presidents. What do you want to make that? Let's use the first letter. Right. All V, all vice presidents are E. All V are E. So what we've done is taken two premises here and we've symbolized them. Some E are not S, all V are E. And then we may conclude that some vice presidents are not social climbers. Some V are not S. Okay, why do we do this? We take a normal argument, we symbolize it, and then he's going to say, look, you actually don't have to know anything about employees, social climbers, vice presidents, businesses. Let's just say that for some of you, all right, that's just too complex. He's going to say, no problem. Let's make it real simple and use things that we really understand. We understand animals, mammals, dogs, fish, right? He's going to say, take these letters that we have up here and symbolize them for these. So what he's going to say is make these two premises true by using these substitutions. So some E are not S. Some animals are not mammals. All V are E. All dogs are animals. He's going to say if you substitute with these right here inside these, okay, no problem. We could see that these two premises are true. Again, this is the abstract form. This is you taking something that you know about clear as day and you substitute in. And he's going to say, now once we do this, is the argument valid or invalid? All right. Some V are not S. Some dogs are not mammals. Ah, there it is. The conclusion's false. So he's going to say, we don't have to know anything about the contents right here or the language going on. We could just symbolize that. And we do. We symbolize it. Then we can substitute in what we do know about animals, mammals, and dogs right here. And he's going to say, if you have two true premises and a false conclusion, can that be valid? No, it's impossible to be valid. Because remember, a valid argument, you assume the premises to be true. The conclusion must be true, but we just showed you the conclusion's absurdly false. And he just maps it out here. So he takes the abstract form, he substitutes it, and here's what we get. Some animals are not mammals. True. All dogs are animals. True. Therefore, some dogs are not mammals. Totally false. Again, you can use this. Anyway, we'll just stop there. Okay, so abstract form, substituting, what you get, totally, obviously, absurdly false. Conclusion. So what's the point of all this in this section? And you're going to see this in your homework that I'll give you a few examples of now. We want to prove that the argument's invalid, and Hurley's going to say, all right, in order to do that, let's take whatever example we have, like this one. Let's keep all these letters like all are, right? And then let's take whatever, migratory waterfowl, and let's substitute and give it a letter. Now, right here, this is interesting to note. Migratory waterfowl, in our earlier example we just saw, we would make that M, right? M as in Mary, just to make it simple. And he makes it A. So I would say, Hurley, to be a little bit more consistent, you should say all M are B and all G are M. You know what I mean? You take the first letter of the word And what he does is he just says all geese are migratory or whatever, all C or A. And I would say, no, just make the letters match right here. Okay, this will make sense when we go to the homework example, okay? But before we get there, here's something to note. In your homework, whatever you have, whatever kind of, examples you have with language, he says, strip out all the language, keep these words, all, no, some, are, not, if, then, either, or, both, and. Keep all those words and substitute in, a letter for, like movie stars or actors. So here's what he means. You read this, right? And he says, keep all these main words in order to reduce the argument to its form. We just want a simple form. So we can see this. There's a premise, right? So right here we have an example. Which one's the premise? This one, right? Because, go back to your earlier section in chapter 1, because is a premise indicating word, right? That's easy to see. And we know that this is a premise, so let's symbolize it, right? Let's strip out all the language. We keep the all, we keep the are, we keep the are. All M, all movie stars who are famous, who are F, are actors, are A. All M who are F are A. And then this is the conclusion. All M are A who are F. So this is just an example of him taking a premise and a conclusion. Again, this is the premise, this is the conclusion. Strip it down to its basic form. How do you do that? You keep main words like all, are, not, some, if, then. You can look at this chart here. That's why I highlighted it, okay, for your homework. And then you can see, if you granted this premise true, would this conclusion follow? He says that you can use even absurd examples, and he gives you an example down here. So up here, sorry. So he'll say, this example, if the government imposes import restrictions, the price of automobiles will rise. Therefore, since government will not impose import restrictions, it follows that. And you're thinking, okay, look, I don't work for the government. I don't know how automobiles are imported, this and that. And to Hurley's point, you don't have to know anything about this to know if it's a valid argument. What you do, strip it down and symbolize it into its basic form. So in that earlier section I just showed you down below, he says keep the if. The is not there. Then is not there, but it's implied because remember in our earlier sections we have a if, comma, then. So he says if then, if what? If government imposes import restrictions, comma. So he says let's take everything right here and make it one sweet simple letter G. If G, then P. Then P. Now this is tricky. It says therefore since. When he does this, therefore is telling you a conclusion's coming, right? Since tells you a premise is coming, and then you see a comma. So we say this whole thing is the premise, and then this is the conclusion. So if this is the premise, how do we symbolize it? G. So he says the government will not impose import restrictions. Will not, so it's not G. Then we know this is the conclusion. Therefore, since, so the since is the premise, and then right here, it follows that. Price of automobiles will not rise, so not P. So you symbolize it into its basic form, and you see a pattern. If G, if government imposes import restrictions, and notice down here it says not G, will not impose government restrictions, then P, then price of automobiles will rise, then we see not P. It follows that price of automobiles will not rise. So take this whole thing, put it in its real simple form, and then he says, look, maybe you don't know anything about government automobiles. All you want to know is this whole thing valid? Well, how do you do that? There's a different way to do it. You symbolize it, break it down into its most simplest form, and you say, if these two were true, would this follow? Because that's the whole point of this section. We want to know if it's valid, right? He says, use the substitution like we did earlier with mammals, dogs, things like that. And he says, you can even use an absurd example. If G, then P. He says, And then he says, let G stand for Abraham Lincoln committed suicide. What? Let P stand for Abraham Lincoln is dead. Okay. And he says, now let's stick that up here. So if we do that, and we take this form, we substitute it using this. Now let's see if it follows here. Let's see if this argument's valid. If Abraham Lincoln committed suicide, then Abraham Lincoln's dead. Okay, seems true. This one, Abraham Lincoln did not commit suicide. Okay, that seems true too. Why? Because he was actually shot. He was assassinated. So we know that these two are true. He says, if these two are true, would this one follow? Therefore, Abraham Lincoln is not dead. What? Oh, I got it. We know he's dead. All we want to know is this argument up here valid? Well, maybe you don't know about government and auto bills. No problem. So you take that, you substitute it, strip it down to its basic form. No problem. You strip it down to its basic form and represent it with letters. Then you substitute in things that you do know about. Then you can get the obvious absurd example. These two are true. This is totally absurdly false. Therefore, what is this? Is this whole thing valid or invalid? Think about it for a second. These two are true. This is false. Yes, the whole thing's invalid. So he says, that's it. That's all I want you to do in this section is take an example, strip it down to its basic form, substitute in things that you know about, then substitute that language in. And if you have two true premises and a false conclusion, you know that the thing's invalid. Okay. That was a lot, right, of me unpacking. You don't have to worry about this part here. You can read it, but I basically have just unpacked what you have to do for your homework. And he says right here in this section, any term or statement will work. What does he mean by that? He means when you finally substitute in, he says any statement or any term will work. You can use animals, dogs, mammals, toys, whatever. All you want to do is make the premises true and the conclusion absurdly false by using your own substitution method. Now we're going to see this in examples, okay? So here's examples, and your mind tap will have slightly different ones. Use the counterexample method to prove the following categorical syllogism is invalid. In doing so, we suggest the following given text. Me, if I were you, I would think about Hurley's example. So right here, number one. All galaxies are structures that contain black holes in the center, so all galaxies are quasars, since all quasars are structures that contain black holes in the center. So what you're going to do is each example, look at it, strip it down to its basic form, and symbolize it for me. Then substitute in, then tell me if you have two true premises and a false conclusion when you're done. So let's see this. When you look at this, what's the conclusion? I'll give you a second to look at it. What's the conclusion there? Well, we know that so is a conclusion indicating word, right? So, thus, as a consequent, hence. So we know this is a conclusion, and we know since is a premise indicating word, so we know this is a premise. We know this is a premise, and we know this is a conclusion. He tells us in the earlier section, keep all the words like all, so, since all. And here's an example. If you can't see this, I'll read it to you, or you can enlarge it. You can pause it and take a picture and enlarge it. Premise 1, all G are S. Premise 2, all Q are S. Conclusion, all G are Q. What did I just do here? All G are S. All galaxies are structures. All G are S. So this whole thing right here, and then that comma, that whole thing, we can symbolize it with an S. Here's another premise. All quasars, all Q are. This whole thing here, we can symbolize it like an S. Now notice there's a pattern. Structures that contain black holes in the center, structures that contain all black holes in the center. So when you symbolize it, all G are S, all Q are S, all G are Q. So your S's match up, your G's match up, and your Q's match up. So again, right here, we have it in this left side to its basic form. Then he says, all right, substitute in. He uses the example of cats and animals. All G are S, all cats are animals. Whatever G is, we'll just call it cats. S, we'll call it animals. All cats are animals. That looks true. All Q are S, we'll just say all all dogs are animals. We'll substitute that in, right? And then the conclusion, all cats are dogs. Totally absurdly false. Again, that's what we were doing in this whole section. We want to prove that this argument's invalid. How do we do it? Strip it down to its basic form. We don't have to know anything about black holes, quasars, quantum mechanics, anything like that, right? Just all G or S, real simple. Then substitute in what you know about. We definitely know cats and animals and dogs and mammals and stuff like that and fish. So substitute in things that you know about. And what you should get for all these is 2 true premises and a false conclusion. In fact, it's absurdly false. All cats are dogs. We know that's false. So we know this whole thing's invalid. So for 4, you can take a look at this example. I'll quickly just reveal it to you. No I or P. Some I are not F. Some P are not F. So premise 1, no I are P. Premise 2, some I are not F. Conclusion, some F are not P. You can write that down, okay? Then you can substitute in, and he says, I'm just going to talk about fish, mammals, and cats. So he says, whatever my I are, I'm going to make them fish. Whatever my P are, I'm going to make them mammals. Whatever my F is, I'm going to make them cats. Premise 1, no fish are mammals. True. Premise 2, some fish are not cats. That's true. Fish are definitely not cats. Conclusion, some cats are not mammals. That's false. All cats and all dogs, they're all mammals, right? So he says, we don't have to know about farm workers and decent wages and all that. We could take that, symbolize it like we did to the left, substitute in things we know we're certain about, like fish, cats, mammals. Those aren't debatable. Those are obvious to us, right? Then read it to yourself. Are the premises true and the conclusion false? Yes. Same thing down here in this section. In this section down here, he's going to, instead of using terms, he's going to use statements. So if animal species are fixed and immutable, then evolution is a myth. Therefore, evolution is not a myth since blah, blah, blah. Where's the conclusion? Yeah, therefore. So we know that's a conclusion, and we know that these two are premises, right? So translate your premises out. What would we do here? If animal species are fixed and immutable, then if A. If A, then E. So whenever you have an if, just take the next word and use the first letter of it. So we're going to use the first letter here, E, first letter there, A. So if you want to see this whole thing, if A, then E. Premise 1, if A, then E. Premise 2, George Washington is dead. Sorry. I confused myself. Premise 1, if A, then E. Premise 2, not A. Conclusion, not E. And then he says, let's substitute in some totally absurd examples. If George Washington was assassinated, then George Washington is dead. George Washington was not assassinated. Those are both true. Then the conclusion, does it follow? George Washington is not dead. Dude, he's totally dead. He died a long time ago. So for all these examples, you will do the same thing. You'll, whatever it is, strip it down to its basic form. And how do you do that? Again, as a reminder, he says keep all these main form words. Then you substitute in things you definitely know about, and you should get 2 true premises and a false conclusion. And again, the whole point of this section is to prove something invalid. And all that means is even if you have 2 true premises, the conclusion does not follow. And again, the bottom line, just as review, is this. No matter what that language is in for all these examples, you don't have to know anything about evolutionists, patient, patent measures, farm workers. Strip it all down to its basic form, substitute in things that you definitely know about, and then you ask yourself, if the premises were true, would the conclusion fall? No, conclusion's absurdly false. So it's just an exercise of proving arguments invalid. That's all, okay? You can listen to this video a few times to let that sink in. You can look at the examples up above in that earlier section, where even if you had premise 1 and premise 2 true, the conclusion would be absurdly false. You can see that better with the circle examples. And here he says this definitely is valid. You can look at that earlier example. If premise 1 is true, if all A's are B's, and if all C's are B's, we know that all C's are A's. You can see it easier with the circle, okay? I know that's a lot, but you can pause this video, listen to it multiple times, and that is pretty much it. Okay, so thank you for tuning in, and I will see you next time.